Hey guys, welcome back. In this lecture, we will discuss about the term reactive and where it came from. The meaning of reactive in plain English is one who reacts. In day-to-day conversation, it is treated as a negative word, but in programming, it means something else. You might know some of the popular paradigms in programming like procedural, functional, object-oriented, etc. Same way, in modern programming, reactive programming, you can say, is just like another paradigm of programming. If you have worked with any procedural language, you might know that it takes some time from shifting from procedural to object oriented. And same way from object oriented to functional. Because all these paradigms require different mindset to work and master. Going functional from object oriented does not mean that object oriented programming will fade away entirely. But we have to understand it clearly that it's good to take advantage of both the worlds. Because in some use cases, object oriented programming is the best fit, and in some other use cases, functional or reactive may be a good fit. So, in this course, we will keep our focus on reactive programming. Few years back, some of the big companies, some experienced developers and architects came together and signed a manifesto called Reactive Manifesto. You can Google it and you will find a web page on this. Reactive Manifesto defines some of the rules for building modern systems. It says to meet modern demands and to exceed users' expectations, a system should be responsive, it should be resilient, it should be message driven, and it should be elastic. Let's understand these terms one by one. First property is being responsive. To qualify to be the modern application, the application has to be responsive. It means that there should be an upper limit of response time of an application, and an application should respond back to the user within a defined time limit. Think of a computational intensive report where your system servers reports to hundreds or thousands of users concurrently based on different input parameters that are user specific. And it takes some time to create and deliver the report. So to reduce the time taken by the application to generate report or to make this application responsive, there are two things that you can do. First, you can go parallel. You can put so many resources in parallel to generate that report timely. And the other way is that you can receive the request from the user and then respond back with a message that we are creating a report for you and we will send the link on the email when ready. And take the request asynchronously in a queue, create the report, when ready, send the report. So there are tips and tricks to design system in such ways so that even if it takes some time, it remain responsive. Next property is resilient. In resilient systems, errors are not second class. Just like the data, errors and failures are also first class citizens. So happy use cases and failures or errors are equally important in reactive systems. And you should deal with errors gracefully. Let's take an example. Let's say you got a centralized database and your system connects to this database to serve to your users. In happy cases, everything is going smooth. But what about a bad case? Suppose your database stops responding. What should you do now? However, it depends case to case, but some of the solutions may be as a backup plan. If database is not responding, you should serve the data maybe from cache, or if you have a backup database in replication sync, then you can connect to that in case of failures. So in any case, you should have a good backup plan to deal with errors, and this is how you build systems that are resilient by definition. Next comes elastic. Your system must be elastic. Suppose if your system is serving requests and someday the load increased on your system, then your system should be able to deal with that without any manual intervention. In the world of cloud and distributed systems and microservices, handling this situation is quite possible by doing very simple configurations. Now, the fourth property that a reactive system should have is being message driven. Message driven is a mean by which systems can achieve loose coupling. The components of the system should talk to each other by asynchronous communication because this helps in building responsive systems because messaging is non-blocking. Think of WhatsApp and a phone call. WhatsApp is a way to get into some conversation asynchronously, and phone call is blocking. Which one do you like? I like WhatsApp because even if my friend is in a meeting or busy doing something, I can just send him a WhatsApp and he can respond whenever he's free. So this was about reactive systems and reactive paradigm. Some developers at Netflix, which is totally a technology-driven company, worked hard for a couple of years for making their systems reactive. And this gave birth to reactive extension, ReactiveX. They made it public and put it on Git as open source. And the JVM extension for ReactiveX is RxJava. Recently, RxJava 3.0 is launched, so we will be using RxJava 3.x in this entire course. This is totally different paradigm, so don't worry much if you could not get it in first look. Gradually, as you'll practice, you will start consuming this, and I'm sure you will also start liking and using this in your project. So from next lecture onwards, let's first discuss the challenges programmers were facing to make systems reactive and how RxJava is solving them.